So, how I started this process, I just asked a simple question: what what theta would you need to shoot a dart to hit a specific point x meters away? So, how I started this problem was I had to find the initial velocity of the dart as it exits the shooter. So what I did was I pointed the shooter straight up and I shot it 5 times in the air and I measured how far it went up. And then I used that since the acceleration of gravity is always constant. I I used the physics equation final velocity squared equals initial velocity squared plus 2 times acceleration y delta y, which is the change in y. And I found the change, it always shot up about 1.25 meters up. And then I used that to find the initial velocity of the dart. Okay, so now that I have the initial velocity, I can use this equation, delta x equals initial velocity x times t plus 1/2 acceleration x t squared. And I use that to derive the general equation for range, which is that the distance from the shooter to x that the dart goes. And I found it to be initial velocity squared sine 2 theta over 9.8. And then I proved it a couple different times. And then I could actually solve for theta, which is extremely handy, because theta is the angle that I need for the dart shooter to go up, which makes programming a lot easier, as I'll find out pretty soon in my in the 3-dimensional step that I took. So this part is just using the gear ratios that I used to find an accurate amount, so the gear ratio is low enough that each rotation of the motor turns the dart shooter 8 degrees, which is accurate enough so that the motor is accurate within a quarter turn-ish, sort of. So if it that means it would be accurate to a quarter of 8, which is 2 degrees, which is good enough for my application. And then this was the step I took to make make it actually turn left and right instead of just going up and down. So now I'm adding another dimension. It's 2-dimensional now. So this was just trigonometry. It's mostly just if statements, like if x is less than 0 and y is greater than 0, which means it's negative x and then positive y. Just take tangent inverse y over x and then add 90 degrees or whatever. It was mostly just logic and figuring it out. And then the distance is just like Pythagorean a squared plus b squared equals c squared sort of thing. And then this was just proving it a little bit. Okay, now this was the difficult part of my all the calculations I did. So I wanted to ask, what if the dart shooter and the target are on different heights? How would that work, right? So at first I started to I just tried to find the general equation first, which was not smart because it led to basically just a whole bunch of variables I couldn't solve for, and it just got extremely convoluted, right? So it's really hard to solve. I had to do a couple quadratic formulas in a row, and it was just a big mess. So for my next approach, I just actually tried to do an example, right? So I gave it specific values. Theta equals 45 degrees. Initial velocity is known. Y0, which is initial, like the ground level. Y1 was the height, or the maximum height of the dart, and then Y2 was the target, the height of the target. And then I found the time up and time down, and then I used time up and time down to, I used my range formula to find that range. Of course, assuming there's no air resistance. In this application, it's not flying fast enough. Or sorry. Yeah, it's not flying fast enough for it to really matter that much, especially in the X direction. So then I just generalized the problem I just did. So I found time down. C total equals time up plus time down. And then I plugged in all the numbers from the original one into my new equation, and it worked. So I found that my range equaled the, so this would be for all circumstances where the shooter is either level with the target or below the target. I haven't figured out if the shooter is above the target. I don't know if this equation would work for it. I haven't investigated that. So this was the formula I found. It's very long. So it's very hard to solve for theta in this. So then I tried to do a different approach where instead of shooting up, it's actually just shooting left and right, except gravity is gravity would be in the direction of alpha instead of up and down like it usually is, and it wasn't any easier, right? So that didn't work. So since I can't solve for theta, what I did instead was, since I know C++, I designed a program where there's a function called compute range, which it does exactly what the formula is. And then I set up a little user interface with some cues. So what it gets the x and y values of the target, and then it gets the z value, or the height, the second height. And then it goes through a for loop where it compares current range, which is range with angle, and the angle starts at 90 degrees. So basically it'll keep comparing, comparing the range of when the angle is 90 degrees and when it keeps going down until the range of whatever angle this is the same as the entered range, that the range that the user enters. So and then I have a little bit of UI here just to make it a little bit easier for the user to understand what the program is outputting. So if I enter an x value, so let's just say it's 1 meter to the right and 1 meter up, right? And then I say the second height is 0.5 meters. We'll enter, and then it'll give a corresponding angle, 69 degrees, and then that's the program. So you would take that theta, right, and then you go into the Mindstorms, which is the this is what actually connects to the dart shooter. So you would set your x and y values to be the same. You got this, man. Come on. Keep right clicking. Here you go. Okay. So you change your x and y values 1 and 1 and 69 degrees. 69 degrees. And you would run the program. It's not connected right now, but you would run it, and then the robot would go over, like it would traverse the exact units or the exact degree, and then it would elevate. It would traverse the exact degree, elevate the exact degree, and then you would have to pull the release, and it would fire the dart, and hopefully at the target, as long as you input the right values. As well, my C++ program has fail safes, right? So if you enter a value that it just can't reach, like the dart shooter cannot reach at all. So let's say the x value is 5 meters away and the y is 1 meter away. It'll give you an error. That object is out of reach, please try again, right? And if you enter in regular x and y values, but you enter in a second height which is too high, so let's just say it's 6 meters up, it's like 20 feet tall somehow, right? It'll give you the object is out of reach given the initial velocity, which would be 4.9 meters per second, as I measured in the beginning of this whole saga. So, yep, that's my C++ program combined with my LEGO Mindstorms program.